Hello and welcome back to my messy workbench that I've been working on, but I can't seem to ever make any progress, so it's always messy. I guess kind of like an artist's loft, except I'm no artist. Well, I wanted to go over a subject that I've never seen a video on, and that is an RGB1401, specifically the A model, of 13-inch CRT monitors. I hate RGB 1301s with a passion. When somebody tells me that they're having a hard time with one, can I help them? My response is, well, of course you're having a hard time with it. It's 1,000 years old, and everybody has problems with them. Well, they don't have problems with them until they do. And then it's pretty much everything. And a lot of people will say that troubleshooting an RGB 1401 is the same as any other monitor. And in some sense, that is true. But all monitor, or chassis, I should say, have their own quirks and have their own issues that some of them are not as straightforward as others, especially RGBs and ceramics, where they have power management sections of the board that are a little bit more advanced. And so anyway, I wanted to go over this board specifically because I had a customer send this to me, and two of them actually, and I got one of them working, and I wanted to just go over the basics of an RGB 1401 and kind of cover some of the primary issues with this board. Like a ceramics, it has its own set of issues, and there's certain ways to test them. So I've never seen anybody go through one and give a tour of one. So I figured now would probably be a good time to do that. So, yes, it's laid out like other boards. True. And yes, like a ceramics 1401, they manage power with an advanced system that manages the power section of the board, and there can be issues with that are exclusive to it, and I can't profess to be an expert on that, but I'll at least tell you what I do know about them. Power comes in over here on these two. I'll try to rotate this if I can. On this connector right over here, power comes in. And oh, by the way, there are a few different versions of 1401s and 1401As. There's another version that's older than this, where the HOT and the power transistor are the big round ones. The general concept of the board is the same, but it does use the older components. It's probably the very early ones. But power comes in over here and goes through the rectifier. It goes to the fuse, then to the rectifier, and then goes through right over here. There is a fusible resistor. And I bent this one. Now, this one was toasted. This board had pretty much every single possible issue, all of the common issues. It had all of them, so it was a good example for me to film a video on. Here is the fusible resistor that is normally in there. I'm hoping that you can see that. Now, when it was in there, the other side of the broken off part here was on it, and it looked like this. So, it looked kind of like a normal resistor, but if you looked at it from the side, I could see all of this good toastiness that was going on. So right away, that fusible resistor was bad. And so it goes through the fusible resistor, and what I understand is that resistor the power management system is taking a reading off of that to do a cross-check of the expected voltages that are coming in across the board, and possibly even the expected pull that's coming across the board. And I think it kind of does some, I don't know, one of these ICs reads what's going across that resistor. And that resistor also, if the HOT or the power management transistor fries, that thing commonly fries. So that's the first component that you always want to test with a meter. I think it's 1.2 or 2.2 ohms. Let me see. I think it's 1, 2, yeah, 1. I think 1.2 ohms. And so anyway, I'm getting distracted, squirrel. And so that's power management section of the board. Then when you start getting into the high voltage section of the board is when you start having other problems. This big 15 watt, 220 ohm resistor is really common for frying. And you can't base it upon appearance. You've got to test the continuity across it. I've seen them to where they look good on top. And if you unsolder them, you'll see that all of the heat generating resistors are on these metal posts, the standoff posts. And the leads go all the way down into the post, and then it gets soldered on the bottom. I've seen these to where when you get to the bottom of it, it's all toasted out and it's open. So if this resistor is open, the board will not start at all. So you do need to try to find a 15 or a 20 watt, 220 ohm. I see people replace these with 10 watts because that's all they can get. And it's fine. If they don't get toasty hot when the board is running, you're fine. But you might find that a 10 watt gets hot. This, so change the value at your own risk. Then, of course, there's the HOT. And then there's these two. They are what are they? I know I replace them with NTE 375s, but they are, they are two, I have to look at, I'm looking at the board down here, right? It's printed, that's the nice thing is a lot of these components are printed on the board. Two SD 386s. Or NTE 375s, whichever you can find. These are getting harder to find and they're getting expensive. But those two were shorted out. And this power transistor, the 2SC3040, was shorted out. So all three of those were shorted. The HOT was fine and this resistor was fried. But many times on the RGB1401s, and I'll explain this in a second, the normal way to test an HOT is to go from the center post to the outside on a diode tester. Center post outside, it's fine. But if you go to test this diode that's right next to it, it's going to show shorted. But if you look at the meter, you can see the meter. Don't know if you can see that. Well, you'll see what I'm saying here in a minute. It's really close to a dead short. But the only way to test that and really test it is to lift one of the leads off and test it out of circuit, because it is in the circuit with this transformer, with this coil. And so as far as the meter is concerned, it's a dead short. But it was not a dead short. The diode checked fine. But in order to truly test that diode, you've got to lift one of the leads out of the circuit. And you want to test all of these diodes that diode, these diodes over here, and all of these resistors, especially the hot ones, the ones that are on the standoff posts. And when you do a cap kit, always make sure that you replace your caps with the correct voltage ratings. Because, for instance, these are supposed to be 63 volts, but a 47 microfarad, 47, 47 63s. Yeah, I think that's correct. That sounds right. That's what's in it, is a 63. And this one has to be a 160 volt, 100 microfarad, 160 volts. So the voltages are pretty high on those. So if you order a cap kit, you'll be fine. But if you're doing your capacitors a la carte, make sure you look at the voltage ratings. And if it looks like anybody has ever worked on the board before, make sure you go to the schematic. The schematic for this is available for download on New Life Games, if you remember. So you can cross-check those values. Okay, so I just covered all of the primary components that fail on this. I'm not saying that's all of them, but I'm saying that's the primary components that must be tested. And you must test the 12-volt regulator and the 5-volt regulator. You also test those like a diode. You can test from the middle to the outside, and they'll usually both test as a diode. So those are fine. Okay. Now, there's another resistor. Depending upon your board, there's another resistor on a standoff here. And sometimes there's another one. Oh, I think there's another one sometimes in here, or another one in this area. And sometimes there's a C144 capacitor, and sometimes there is not. I cannot tell you what the difference is on the boards that have it and the boards that do not. But there are sometimes some nuances to the board that you look at and go, hey, this is a little bit different. Don't ask. Doesn't matter. If you can find the fault of the board and fix it, it will fire up. Now, while we're on this side of the board, my last note about this side of the board is this. It's really tough to troubleshoot these, especially if you're having a flyback problem. And the reason for that is, unless you're the luckiest person on the planet, you can't get flybacks for these. And don't get fooled into buying a RGB1401B chassis. They do not use the same flyback. So I have never seen an RGB1401A flyback available anywhere. If you ever find any, please send me a message here on YouTube and I'll buy them, because I've never seen them. I have one time purchased an RGB board online, but when it came in, it turned out to be a B. And so, oh well, too bad. So, you can go through these boards and test all these components and say it still won't start up. That's the most common problem with these, is you can't get them to start up. And if you're having flyback problems, then if the flyback's aging, or if it's cracked, or it's already internally shorted, the board will immediately go into internal shutdown. And if you listen closely, especially if you're powering it up with a benchtop variable AC isolation transformer, if you're slowly ramping up the voltage, you may not hear it go into shutdown, but as you're ramping the voltage back down, you'll hear it come out of shutdown when it gets somewhere around 40 volts, and you'll hear it step out of shutdown, and that's indicating that the board is going into shutdown, probably slowly when you're ramping it up, and you can't hear it shut down, but you can hear it come out of shutdown. And they also use, like Ceronics, they use these PRA boards, one for red, and one for green, and one for blue, and one for power management. And then they have this giant remote board for video. Also the same thing. There's one for, this is the analog processing board, transistors for each colors, or resistors for each color, however you want to say it. And then you've got your RGB boards here. So these PRA boards, if you have a board that you cannot find the problem, make sure you look closely at all of the resistors that are impressioned on the board and make sure none of them are burned out. Now, the problem is that the manual for this chassis does not list the schematics for these PRA boards to tell you what the values are supposed to be. So if you see on the power management board, which one is power management? I think, is it this one? I think it might be this one. If you ever have a fried resistor, sorry, I got interrupted there. If you ever have one that is toasted, you can measure it across the leads, the nearest leads. You cannot measure on the surface of the board, but you can find where the onboard resistor, the lead that it goes to, and you can test across it. And if it's open, you can verify that it's open, it's toasted. You can then solder a resistor across the two respective leads for that onboard resistor. Wherever that resistor goes from point A to point B, you can solder on a regular wire wound or a regular quarter watt resistor is fine, and repair them. You would have to post a message and ask what the resistance reading is across that board, and I could give it to you from one of the boards that I have that that is known to be good. So that's about it on this side of the board. Oh, there is one other thing I want to mention that we'll talk about on the other side of the board. But the neck board ribbon cables on these are often very weak or bent until the point that they have broken where they go into the board. So you need to test your continuity from the back side of the board to the lead respective to it on the back side of the neck board. So there's these three that are labeled RGB. They come across here as RGB. And then these three that are over here, which is filament and ground. I think filament and ground come across from over here and just test these three over to there. But the other part of that I wanted to talk about is well, I'm going to actually, I have a tendency to do that. These sit better upside down. So you have to take your tour of this board while upside down. Okay. These boards are known. And every single one that I've ever worked on, unless you have a low hours RGB1401, you're going to have these issues. All of those transistors that we talked about that were mounted to that heat sink up there, and all of those resistors that are mounted on those risers, their solder joints are notorious for popping off the traces. And you cannot trust looking at it and saying, oh yeah, it's fine. And you even need to be careful doing a very casual continuity test you want to make sure that you get your hand down on the resistor somehow and you wiggle it and you look at it under a magnifier like we're doing here, but you get it under a magnifier and you look at it like that and you get under there and you wiggle that resistor and you look at those traces very close up and you make sure that the edge of the trace is not wiggling. And if you see it wiggling, like we've had to do here, where this one was wiggling, and sometimes you would continuity test it from here to here, and it would be fine. But depending upon how much it was touched on the top side, this was fixed before I got it, but this is a very common fix. But the other part that I had to do was, I'm going to zoom back out here, sorry. Where this lead connected to this trace had a weak connection, the trace had lifted off the board. And all it takes is shipping this board back or somebody picking it up with their hands and pressing on that resistor, and it would pop that solder joint off that trace. So what you do is you take your fiberglass cleaning tool and you wipe off all of the protective coating, and then you solder pretty far back onto that trace so that you've got a good amount of holding power, holding that solder joint down. You get heat damages, you get heat damage on all of these resistors and all of the traces around them. You can see here where I did the same thing. I had to clean it and spread that solder joint out. Cleaned it and had to clean the trace and spread that solder joint back. You have to do that on a lot of these. Clean it and spread that solder joint out. And then also you want to reflow all of the leads on the flyback. And really importantly, and if I can find a way to insert a photo, I'll try to do, into this, I will. But all three of these wires, you could see air around all three of those ribbon cables. And that would cause you to have a terrible video. If you had video at all, you would probably have video if the HOT started and the flyback started. You would have fuzzy video, or you would hear the monitor running, but you wouldn't have a picture because your filament wouldn't be running. Your heating element wouldn't be heating up at all. So all three of those must be reflowed, preferable to remove the solder and put flux on it and reflow them. And these three also, over here. The RGBs. These three, same problem. They must be reflowed. You've got to reflow the video input, and you need to reflow the remote ports. Look at them very closely under a magnifier and reflow them if they look dry at all. Now you can see a lot of shining going on this board, and that's because 80% of the solder joints on this board need to be reflowed. Even if they just look a little bit dull, but you don't see a crack, reflow it anyways. And the yoke the yoke pins all need to be reflowed. Take some or all of the solder off and then flow new solder on. It's a good idea to put the connector or a connector or tape them together or something, tape them to the board, because these pins have a tendency, if you get the solder hot, they'll just drop out of the board. They're known for not fitting really tight. All of the connections on the bridge and the power connectors All of those need to be reflowed, as do these caps. And a good idea to reflow, take a look at the PRA boards and do any reflowing where you see bad connections there. And many times you'll replace the shorted transistors, or you'll replace the, that resistor that I showed you, or some of the other transistors could be shorted. This transistor here, there's a couple of transistors in here that need to be checked carefully. You can replace all those and the board won't start. But if you go to the back side of the board and you spend half an hour or 45 minutes reflowing all these solder joints and getting them good and shiny and flowed to the traces, you connect the board back up and voila, it starts. Imagine that. So even though some of the solder joints look good, you need to go through them and you need to spend some time on these boards, and you go from each of these leads and you test from point A to point B, and you just make sure that these solder connections go all the way through where they're supposed to go. Nope, that one's right there. And you just test continuity on these. And go from point A to point B, and you may find that you get to one and go, oh, look, that trace that's supposed to connect from here over to, where does that one go? Over to here, you may find that one of these real small solder joints doesn't have continuity. And that's the reason that the board won't start. Then when you're done, spend a lot of time. RGB did not do a good job of cleaning flux off of these new from the factory. So there's a lot of flux that's baked on these that's many, many, many years old. This is after I've gone through this. I spent about half an hour on this board cleaning flux off of it. And then every time it dries, I come back to it. And this more, this another spot, this another spot. And you got to just keep cleaning and cleaning and cleaning and peel the layers off because these get really dirty. So I'm sorry that this is such a long video. The only other thing that I wanted to cover on these is the remote board. These potentiometers are getting really hard to find, but they are available. I think for the most part, they're all 5K ohm. But it's a good idea to come look at these and look at them under magnifier and make sure their connections are good. There's a little bit of heat damage in here on this one. I think I reflowed this board, actually. This is my board. This chassis didn't come with one. But these are tough to find. But do a reflow on this too, and maybe even check the continuity through these, because sometimes these lose continuity and you have to replace them. You may not be able to get this exact type with the fingernail wheels on them, but you can get some that fit in here, the 4 posts that fit in them. Bob Roberts has them that will fit. If you send them a picture of it and tell them the value, they have them that will fit. They may not be the exact same type, but they will work in it. Okay, well, sorry to ramble on, and sorry I got distracted so much, but any other input anybody has on RGB1401s, please jump in, chime in here. If you learn anything special when you're working on your own, please post. It will help us all. We're in this together. These boards are getting really old, and unlike ceramics, there's not a billion of them. There might have been a million of them, but there's a ton of ceramics 1492s out there, and 1793s and 1493s. But these all suffered a lot of heat damage, and a lot of them just got recycled or thrown away. So it's an unfortunate situation that we're in if we have an RGB tube that's good, but we don't have a chassis to drive it. So that's all for now. And until next time, that's all. Happy soldering. I knew I was going to forget something. I wanted to quickly show the other format of RGB1401A. I call it the older version. I'm sure it's the older version. This one's blue. And you can see that the general format of the board is the same. This one has the two capacitors over here. It has a little bit different circuitry going on over in here. And this one has the big HOT and the power transistor. This one, the HOT, the MTE94, was shorted. And I'm trying to think on this. Yes, it tested shorted in chassis, but I did have to pull it to test it out of circuit. And it also has some of these. This one has D1138s in it. Also, was that the other one? 1138s or 1386s? Yeah, 1386s. This has 1138s, and the voltage regulators are over here. So these need to be tested to see if they're shorted. The voltage regulators probably will not be shorted. They could be, but probably not. They're probably fine. But these two are suspect. And of course, these resistors. This one does not have the big, giant white resistor, but it has more of the big, what do they call these? They're wire rounds, or I can't remember what they're called. But anyhow, it has 1, 2, 3, 4, 5 on standoffs, and there's one more down here, and it also has that fusible resistor. I cannot get this board to start. It won't start up. The high voltage will not kick on. I suspect the flyback on this chassis is bad, which is unfortunate because this board had a lot of work that needed to be done to it. It needed a lot of trace work. Here, 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 over here. So we had to do a lot of trace repairs because of the burning that I was talking about. And I still can't get it to boot. So it's either going to have somebody who can put it on a scope to look at it and make an official determination on it, or it's considered a loss. That's the two options. So anyway, I wanted to share that. And the other thing that I wanted to share that I forgot to share, if you haven't fallen asleep by this point in the video, is these boards do not self-discharge. You must discharge them with your discharging tool. If you're me, your discharging tool is a screwdriver with your wire clamped firmly to your screwdriver and alligator clip to connect to the chassis. That's how I discharge. To each his own. But these absolutely will hold a charge. So even if you get one, if you pull one out of a machine that hasn't been run for a while, these are notorious for starting up and in a split second blowing the fuse, or immediately blowing the fuse, or that resistor instantaneously, but they charge the tube. And if you don't discharge it, you're going to get shocked, and you're going to get shocked good. These aren't little tiny pops. These tubes are a audible snap, like somebody has snapped their fingers. So you don't want to get shocked by this one. So just remember that. This is not a Ceronix 1492 that has an automatic discharge resistor built into the flyback. These do not discharge. So there's your safety warning. I always try to get one into my videos. All right, farewell for now. Thank you for tuning in.